In the previous video, you learned about one of the two types of bonds that's so strong that it causes atoms of elements to bond together so tightly that they change their properties and become different substances. In the previous lesson, you learned about ionic bonds that cause atoms to form crystals. In this lesson, you're going to be learning about the other type of extremely strong bond that causes atoms to change their properties. This type of bond, though, is known as a covalent bond, and it behaves differently than an ionic bond because it's formed differently than an ionic bond. Let's take a look at what covalent bonds are and the properties that they give to covalently bonded substances. First off, a covalent bond forms basically for the same reason that an ionic bond forms. It just forms in a different way and with different materials. Covalent bonds form because atoms don't have 8 electrons in their outer shell to be stable, and one way that they can get 8 electrons in their outer shell is by sharing pairs of electrons. So here we have 2 oxygen atoms. Oxygen atoms naturally have 6 electrons in their outer shell, not 8, and therefore they're not stable. But if they share 2 pairs of electrons between them, with all of the other electrons that they now have 8 electrons in their outer shell by sharing. Another element that does this is nitrogen, except nitrogen shares 3 pairs of electrons between 2 atoms because each nitrogen atom naturally has 5, not stable. But when it shares 3 pairs with the other unshared pair of electrons that each nitrogen atom has, there's a total of 8 electrons around each nitrogen atom. The same can happen even if the atoms aren't the same type. What about carbon dioxide, which has 1 carbon atom and 2 oxygen atoms? Carbon has 4 electrons in its outer shell, not stable. Oxygen has 6. If the carbon shares 2 pairs with each of the 2 oxygen atoms, the carbon has 8 electrons around it, and each oxygen with its 2 unshared pairs has 8 electrons around it as well. So do you see how by sharing electrons, atoms can also form stable arrangements with 8 electrons around each atom? Now, there are some properties that this gives to these substances that ionic substances didn't have. For example, first of all, these substances typically form between nonmetals and other nonmetals. Now again, when you're working with chemicals, there are always some exceptions. Sometimes, rarely, metals can form covalent bonds with nonmetals. However, anytime you have a nonmetal bonded to a nonmetal, like in this case we have oxygen, which is a nonmetal, carbon, which is a nonmetal, and hydrogen is a nonmetal. Anytime you have nonmetals bonded to other nonmetals, they must be sharing electrons with a covalent bond. Another characteristic is that they form molecules. Those bonds cause atoms to come together in groups that are molecules, not crystals. Those bonds cause the atoms to come together in individual groups of molecules instead of repeating patterns of crystals like an ionic substance did. Another pair of characteristics that you need to understand in order to fully grasp why covalent substances behave the way they do is that the bonds within the molecules are really, really strong. There's a double bond, 2 shared pairs of electrons holding oxygen to carbon in this formaldehyde molecule. And those hydrogens have a pair of shared electrons with the carbon. Those bonds holding that molecule together as a unit are really strong, directed inward into the molecule. But here's the other thing that you need to understand. Even though the bonds within the molecules are really strong, the bonds between molecules aren't really all that strong. Formaldehyde molecules like this can come together with other formaldehyde molecules, and they can form these weak bonds between the molecules. Remember when we talked about dipole-dipole bonds? We'll be talking about those again more later on. But remember how hydrogen usually has a positive charge sticking off on the outside? And you can see that oxygen has extra electrons on the top in these formaldehyde molecules. So there's a negative charge coming together near a positive charge, and they're going to pull together. But with covalently bonded molecules, the bonds between the molecules aren't all that strong at all. Now again, let me repeat that. The bonds holding the molecules together within the molecules are really strong, but the bonds between one molecule and another molecule aren't really all that strong at all. In fact, formaldehyde at room temperature doesn't even form solids because the molecules don't pull together that strongly. Instead, it forms a liquid because the molecules are able to slide past one another. It's not a very strong bond between molecules. And there are other covalent substances like oxygen, which we looked at before, which have absolutely no reason to want to come together at all. So oxygen's just going to stay a gas at room temperature. What this causes to happen with covalent substances is that they usually have fairly low melting and boiling points to very low melting and boiling points. They can be solids at room temperature, but they're also very likely to be liquids or even gases at room temperature because the molecules don't bond together very tightly. Let's take a look at formaldehyde once again, and we're going to see what happens when we put formaldehyde together with water. When covalent substances dissolve in water, and there are many of them that really don't dissolve very well in water at all, but when they do dissolve in water, instead of splitting apart like ionic substances did, the molecules of covalent substances just spread out in the water. The water molecules surround the covalently bonded molecules and push them away from each other. Notice that the molecules remain intact and there's no positive or negative charges on the outside. What that means is that even when you dissolve a covalently bonded substance in water, because there's no charges, there's no path for the electrons to really follow, the electrons are not going to flow through that covalently bonded substance. Covalently bonded molecules hold on to their electrons so tightly in those pairs, they don't allow electrons to flow through them. Therefore, covalently bonded substances are terrible conductors of electricity. So now you understand what a covalent bond is and some of the properties of covalent substances. Covalent bonds form between nonmetals when they share pairs of electrons to fill their outer shells. And when they do that, they make molecules that are very strongly bonded together, but don't bond very well to other molecules nearby. And that's what gives covalent substances their properties.